Hi Geometry, this is Unit 5, Lesson 16, page 625 of our workbooks. We're going to start talking about surface area and volume in our problems. So let's take a look at 16.1. The zoo wants to give elephants as much space as possible in a rectangular enclosure meant for feeding. It has 180 feet of fencing. What should the dimensions of the rectangle be? So the 180 feet of fencing perimeter, that's the fencing that's going to go all the way around all four sides of the pen. So for example, 180 divided by four sides would be 45. So I could have a 45 by 45 enclosure for the elephants to walk around in. Or if I make one of my sides, let's say 50, the other side is 50, and that's 100. So 180 minus that 100 would be 80. So there'd be 40 and 40 left for the other two sides. 50 plus 40 plus 50 plus 40 is 180. Or I could increase my side length and make it even a little longer, but it'd become a little bit more narrow. I could do 55 and 55. That's 110. And 180 minus 110 is 70. So that would leave 35 and 35 feet of fencing. I could make it even longer. I could make it 60. The dimension, I could make it 60. 60, that's a lot of space to run back and forth right there, 60 feet. And 60 and 60 is 120. 180 minus 120, what is that, 60? So then now my width would be 30. It'd be a much more narrow pen. So all four of these rectangular enclosures have 180 feet of fencing. Each one of them have the exact same perimeter. So which one of them has more area? Which one of these have more area for my elephants to live in? So remember, the area of a rectangle equals base times height. So I'm going to go through with a different color, and I'm going to write the area of that enclosure inside. So grab out your calculators. A 45 by 45 rectangular enclosure would have an area of 2,025 feet squared. So the area of that one would be 2,025 feet squared. How about the 40 by 50? 40 times 50 is 2,000. Oh, this is actually slightly less area for my elephants to run around in. How about the 55 by 35? Well, that would actually be 1,925 feet squared inside. Well, that's even less area for my elephants to run around in. Well, what about the 60 by 30? 60 times 30 is 1,800. I'm going to write it kind of diagonal so it fits. So that's an even smaller overall area. So if I think about my constraint, my 180 feet of fencing is my constraint. It looks like my maximum area, so my max area occurs at my 45 by 45 enclosure, and that my max area is 2,025 feet squared. So it looks to me like the best dimensions would be a 45 by 45 enclosure. And actually, write this down, please. The largest area is always a square if perimeter is the same. That's in parentheses underneath. So the largest area is always a square. So if your perimeter is the same, so the dimensions around your rectangles are all the same, because remember, a square is a rectangle. A square is just a special rectangle where all the sides are the same. So if you're looking at a series of rectangles that all have the same perimeter, the square will always have the biggest area. So it's kind of a nice thing to know. So let's take a look at the next part of our page. So number 1 says, find a set of dimensions for a rectangular prism with a volume of 60 cubic units. Calculate the surface area of your prism and add your data to a class chart. Okay, well, let's first think about what our rectangular prism looks like. So I'm just gonna draw some sort of base here. It looks a little squarish. Draw another one up here. It's just a rectangle though. You don't have to be exact about anything there, and attach it. So remember that a rectangular prism, its volume is the length times the width times the height. My volume is length times width times height. So, and we'll talk about surface area in a moment. So my volume. So I'd like to make a chart. This chart is going to have 5 columns and it's going to have 5 rows. So take a moment to pause this video and draw this 5 by 5 chart into your workbooks, keeping in mind that the surface area work should be a very long, very wide column. The actual surface area answer, the 5th one, doesn't have to be as wide. Surface area took a lot of space to write. So the surface area work should be a very wide column. Welcome back. So let's put some dimensions. Let's do a very narrow rectangular prism, something very tall and narrow, kind of like the idea of something that an architect could put architect's plans in, or roll up a map in, but instead of being a cylindrical, it's going to be just tall, 1 by 1 by 60, because I know from my problem, I want the volume to be 60. So if it's 1 by 1 by 60, when I multiply 1 times 1 times 60, I would get 60 units cubed, whatever my units are, units cubed. So then let's also consider something that's kind of like a cereal box. Let's think about a cereal box. It's very, it's kind of wide in front. It's got a very small side, and it's taller. Something like 6 by 1 by 10. And I picked those numbers because 6 times 1 times 10 is 60 units cubed. That's my volume. My volume is supposed to be 60. So now I'm trying to think about another dimension. Well, what about 2 by 3 by 10? Something that's 2 by 3 by 10. That would be 6 times 10, or 60 units cubed. Let's try to think of another rectangular prism. What about 2 by 5? 2 by 5 by 6. This would also be something that would have 60 units cubed. I'm trying to imagine that one. A small front, that's my 2, 5 by 6 tall. Kind of narrowish, but wideish, almost like an Amazon box that we might get, let's say. Okay, so we have these 4 different rectangular prisms, but they all hold the same amount. So if these were boxes and I could pour, sand inside of them, they would all hold the same amount of sand, but they're a much different overall shape, 3-dimensional shape. So let's talk about the surface areas. The surface area, there are 6 sides. If you want to take a look at my first one, I've got a top and a bottom. Those are the same. In my cereal box that I drew, you've got a bottom to your cereal box and a top. You also have then 2 sides. So over here, I have a side and I have a side here. And on this one, I've got a narrow side on my cereal box and a narrow side on my cereal box. And I also have a front and a back. So I have a front, and then on the back side, I have this exact same green side. There are 6 sides, top and bottom in blue, sides in red, front and back in green. 6 sides. So to fill in for our surface area, we have to add up the area of our 6 sides. So when I'm starting with the first one, making sure, so I'm going to do the top and the bottom. So my top is 1 by 1, and so is my bottom. So I have 2 of those, and they're 1 by 1 in area. I'm going to add to it my red sides. My red sides, there's 2 of them, and they are 1 by 60. So 1 by 60 in area. And then I have a front and back. My front and back were in green, and they are 1 by 60 tall. So there's 2 of them. That's 1 by 60. So 60. So I'm going to go through and do my, sorry if that was hard to read. Let me erase that and make my 60 clearer in green. So 1 by 60 units in area. So then I would do what's in parentheses, multiply by 2, and I'd add up those 3 numbers. When you do that, you get 242 units squared. So just as a reminder, if I filled this package with sand, I'd need 60 units cubed of sand. If I wrapped this up like a gift around the outside, just or this outside surfaces, I'd need 242 square units of wrapping paper, 2 entirely different dimensions. So let's take a look at my cereal box. So going back through this again, if you had trouble following before, let's think about our top and the bottom of our cereal box. There's 2 of them, and they are 1 by 6 rectangles in area. And then let's look at my red sides. So there's 2 of them, and they were also 1 but by 10 in height. So this is 1 by 10 rectangles on the side. And now let's do the front and the back of my cereal box. So my front and my back of my cereal box was 6 in width and 10 in height. So this is 6 by 10. Again, I would go through and multiply each set of parentheses, and then I would multiply by 2, and then I would add those 3 numbers together. When you do that correctly, you should get 152 units squared. Again, if I wanted to fill my cereal box with cereal, I would need 60 units cubed of cereal. That's like a volume, a 3-dimensional volume. But if I wanted to wrap my cereal box up with wrapping paper, I would need a large piece of wrapping paper, cut off my wrapping paper roll, of 152 units squared. It's flat. It's a flat dimension. My 152 units is a flat dimension. I'm going to use that to wrap up my sides. My 60 units squared is a 3-dimensional dimension. That's to fill up my box. So pause this video and let's practice surface area. We're kind of new to it. Find the surface area of my next 2 boxes. Taking note that I did not draw this one on the page. I did draw this one. It's right here. So you might do the 4th row first and then see if you can fill in for the 3rd row. And come back to this video after you're done. So I hope you were able to get the 112 units squared and the 104 units squared. If you need a little more support for this problem and you were absent from our Zoom when we did the notes, just come to office hours and I'll talk to you about it. But what I would like you to notice is how our volumes are all equal in these boxes. But look what happens. My surface area has decreased. My overall surface area has decreased as I've changed my box and really made it come, this box is tall and narrow, and then as I move down to this box, it is wider and shorter. So my surface area has gotten smaller as I've done that. So let's take a look at number 2. It says a lithium-ion battery contains a rectangular prism made of lithium. The energy in the battery is proportional to the surface area of this prism. So it means that you want a lot of surface area, I'm going to abbreviate as SA, for more energy. If your energy is relative to your surface area, then the more surface area you have, the more energy you would have. So it says it has a fixed volume of 60 cubic millimeters. Ooh, look, it's just like problem number 1 above. It says find the dimensions of a rectangular prism with this volume that maximizes its surface area. Well, we can see above that the dimensions that maximize surface area makes the most surface area would be a very narrow, tall battery. 60 by 1 by 1 by, 1 by 1 by 60. And so that gives me a surface area of 242 millimeters squared. So let's take a look at the next page in our workbook. Before we go on, for my students, we've not encountered any spheres yet, and I'd like to practice doing both the volume and the surface area of a sphere. So we haven't looked at these formulas in our classroom yet. So here's my sphere, and I want to give you two formulas for it. One, the volume of a sphere. The volume of a sphere is 4/3 pi r cubed. And the surface area, abbreviate SA, the surface area of a sphere is 4 pi r squared. So let's use the diagram in our workbook to try this out. Let's make R 5. So I'm just creating a new problem in the book. So we're going to find both the volume and the surface area of the sphere. So R equals 5 inches. So let's plug that into our formula. Volume equals 4/3 pi times 5 cubed. Remember, by PEMDAS, we have to do exponents first. So 5 cubed is 5 times 5 times 5, 125. So my volume equals 4/3 pi times 125. And so if you multiply 4, and remember this 125 is like over 1. So if I multiply it times my 4/3, I would do 4 times the 125, which is 500. And then it's still over 3 times 1 or 3 pi units cubed. And you could do 500 divided by 3 if you wanted to. I think it's around 166.3 repeating, so decimals are fine there. You could also multiply by pi on your calculator. I'm just going to stop there and leave my answer in this format for now, but there's quite a few forms you could leave that final answer in. So if this was a shape of a bath bomb or a basketball or just something that's spherical, then the amount inside, the volume, the interior volume, would be 500 divided by 3 times pi units cubed. Well, what about the surface area? What about if I wanted to somehow wrap this or paint this or coat the outside of my sphere, the area around it? That would be surface area. And so my surface area would be 4 times pi times 5 squared, and I would get my surface area then would be 4 times pi times 25, or my surface area would be 100 pi units squared. So that is around the outside of my sphere. That would be my surface area. So keep those two formulas handy as we move forward in our unit. The volume of a sphere and the surface area of a sphere, since we have yet to use those. So now let's move our attention over to this cylinder. I'm going to cross this out since this isn't the directions for what I'm doing with you. So let's calculate the surface area and volume of this cylinder. Let's give it some numbers. So I'm going to say that my radius is 6. So here, if my radius is 6, my height then is 4/3 times 6. Put that over 1, cancel the 3 and 6 to 2 and 1, and it looks like that makes my height 8. So my cylinder has a radius of 6 and it has a height of 8. So let's go ahead and do our volume. We've been doing volume of cylinders. So pi r squared h. This is pretty easy for us now. Pi times 6 squared times the height of 8. So my volume is 36 times 8, or 288 pi units cubed. Again, this is the volume that would fill up a cylinder with this dimensions. So how about surface area? We haven't done surface area yet. Let's write this down. So surface area of a cylinder, there's 2 circular bases. So it's 2 times the area of your base. So let's write the area of the base as big B. Then it's also the surface area of the sides, which we're going to talk about in a second. We've talked about before briefly. My side is really a big rectangle. And so the area of that rectangle is going to be big C, circumference, times the height. So this big C stands for circumference. So let me talk about that for just 1 second. So my surfaces of this cylinder, I have 2 circular bases. These guys have areas of B units squared, and there's 2 of them. That's my 2 times big B. And then I have this rectangular side that wraps all the way around my circles. So the length is my circumference. It's the distance around my circle. This distance around the perimeter of my circle is C. That's my circumference. And then this is the height of my cylinder. So the dimensions of this rectangle is C times H. That's my C times H in my surface area formula. So now I just have to plug in for all of this. So let's do that. So my base area is pi times r squared. So let's write that, 2 pi times r squared. Okay, great. We'll fill that in a moment. Circumference, 2 popular formulas. They're completely equal. Circumference is the diameter times pi, or sometimes we write it as 2 pi times r, since 2r is also the diameter. So both of those are formulas that you have worked with at some point before, years ago, but we're going to use it again today. So I wanted to refamiliarize yourself with it. And why don't we just use the diameter times pi? So this is going to be my big C is diameter times pi times my height. So now let's fill in for each of these variables. Let's talk about where I get my numbers. So 2 times pi times r squared. Well, r was 6, so that's 6 squared. Plus the diameter. Well, the diameter is all the way across my circular base. So if my radius is 6, my diameter then would be twice that, or my diameter is 12 times pi times my height. And I already determined my height to be 8. So I've got a lot of numbers in my formula right now. So let's clean this up a little bit. By the way, I want to make sure my drawing is separate from all my math. So 6 squared is 36. 36 times 2 is 72 pi over here. Plus 12 times pi times 8. The 12 times 8 part is 96. So 96 pi. That cleaned up nicely. I can add these 2 together. They both have a pi part, and I get 168 pi centimeters squared. So that's the outside. So my volume, if I wanted to fill this up with some material, some liquid, some object, sand, I would need 288 pi units cubed to fill it up. If I wanted to wrap the outside with wrapping paper or paint the outside surfaces, I would need 168 pi centimeters squared of that material to wrap up the outside. So just wanted to revisit those ideas. This is lesson 16, part 1. I'm going to continue lesson 16 with the next activity in a second video called part 2.